Like many others, Marcus Allen watched the Apollo moon landing live on television, and at the time, he applauded the evident success of those missions. After attending a lecture many years ago which questioned the validity of the moon landings, Marcus decided to carry on his own research. So now, how many years ago was it that you first attended that lecture that kind of turned your worldview around?
It was in the early 90s. I think it was 92. It was in Glastonbury. Now, most people are familiar with Glastonbury for the music festival, but this is a different series of lectures that are held in Glastonbury regularly. And it was just one. He was talking about something quite different. He was talking about megalithic architecture, I believe it was. But he was showing a lot of photographs, and he just almost in passing said, well, of course, you know all those photographs allegedly taken on the moon. He said they weren't taken on the moon. They couldn't have been. I thought, what is he talking about? What a stupid thing to say. Now, I was trained as a photographer in London back in the 60s, so I was familiar with the cameras that I subsequently discovered were used, the Hasselblad cameras, the films that were used, Kodak Ektachrome transparency material, black and white film. I was familiar with all that. I knew what cameras could and couldn't do. And I knew what film could and couldn't record. So I went out and bought a set of photographs, which I did, and I looked at them. I thought, whoa, I can see what he's talking about. I can see there's a problem here, because the half a dozen photographs that I looked at, many well-known photographs, man on the moon and Aldrin coming down the ladder and the Apollo 15 lunar rover and all that, they were just sort of basic photographs. But I could see there was a slight problem, because photographic film has to be exposed correctly, especially if it's reversal film, i.e. transparency material. If it's not exposed correctly, you ruin the photograph, you've got to start again. And these photographs were brilliant. In my view, almost professional level photographs. But they were supposedly taken by astronauts who were in a place they'd never been to before. I was intrigued enough to follow it up and discover a little bit more about Apollo and the conditions on the moon and everything that went along with that. And the more I discovered, the more I found that there were anomalies in the photographs. There were anomalies in the story. And it just didn't seem to hang together the way it should have been, because if something doesn't seem right, it may well not be right.
Do you, just for the record, do you believe that the photographs were likely taken elsewhere, not on the moon, but that it is possible or not possible that man landed on the moon?
That's a good point, because there is a quite distinct difference between the two. My view is that the photographs could not have been taken on the lunar surface, and we'll come to the reasons why that is the case maybe a bit later. As to whether man has landed on the moon, I have seen no evidence that I can find to show that that has happened, other than what NASA, God bless them, tell us happened on Apollo. Because no other nation has claimed that humans have landed on the lunar surface. There have been several nations which have landed unmanned craft on the lunar surface, and the first to reach the moon with an unmanned satellite was actually the Soviet Union in 1959. Then there were a series of unmanned craft from America and from the Soviet Union that landed on the moon. Landing an unmanned craft on the moon is not a problem. I don't dispute any of that. What I do find a problem is landing humans on the moon and then getting him back to Earth. That is the real difficulty I have in accepting as being true.
All right, so let's focus, no pun intended, on the photographs, first of all. And as you say, you're familiar with the Hasselblad camera. That was the camera that was used. Now, Neil Armstrong and Buzz Aldrin, they wandered around, supposedly, on the surface of the moon for about 2.5 hours. How many photographs did they supposedly take in 2.5 hours?
On Apollo 11, there was only one camera that was being used to take all the photographs on the lunar surface. As you say, that Armstrong was on the surface for just under 2.5 hours, Buzz Aldrin slightly less time. And in that time, they took 121 individual photographs on the lunar surface. Now, That's about one a minute, a bit less than one a minute. I mean, that isn't a problem to take that number of photographs, because obviously that was something that they wanted to do, to show where they'd been. You know, it's like anybody going on holiday. You take photographs of where you've been so you can show the folks back home what it was like. But they couldn't have been on the lunar surface to take those photographs that we're told that they did. And the reason for that is actually quite straightforward. But it was only something that I discovered in September 2018, just over a year ago, when I attended a lecture given in London at the British Interplanetary Society by a gentleman with the name of Phil Pressel. Now, Phil Pressel was an engineer, a very, very competent engineer, who worked for a company called Elmer Perkin in Danbury, Connecticut. And their job was to build photographic cameras to be flown on the Hexagon spy satellite, which had been launched in 1971. And it used photographic film, because at that time the digital equipment was not sufficiently advanced to be able to be used to obtain the images or the quality of the images that were required by the security services, CIA, the NSA and so on, who wanted to find out what was happening in the Soviet Union. Phil Pressel was extremely proud of his achievement, and he had every reason to be so, because he had developed, along with other people at Elmer Perkin, a twin camera system so they could take stereo images, which from a stereo image you can determine the height of a rocket or the size of a building or the length of a ship. And the satellite was to be flown on a polar orbit launched from Vandenberg Air Force Base in California. On a polar orbit, it would just circle the Earth from North Pole to South Pole, and as the Earth rotated underneath it, it would take photographs, and every 24 hours or so it could take photographs of the same place. So it was a good system. But one of the points that he made, almost inadvertently, he said, well, of course, the film had to be kept pressurized. I thought, why does the film have to be kept pressurized? And the reason is that in a vacuum, photographic film outgasses, which is a technical term for basically it loses its chemicals. Photographic film is made of a chemical emulsion, which is coated onto a polyester base, and the chemical emulsion will outgas in a vacuum. So it had to be kept under a very small pressure, 1 pound per square inch pressure. Mount Everest is just short of 29,000 feet, and at that height the air pressure is about 5 pound per square inch. You go up to about 60,000 feet, it's about 1 pound per square inch. So a spy plane flying at that altitude wouldn't actually have a problem. It's when you get beyond what's called the Kármán line. The Kármán line is the point at which space begins, if you like, and the atmosphere ends. That's at 62 miles above the Earth's surface, quite high up, about 320,000 feet. If you get above that height, you're into space. You're not yet into deep space, but you're into space, and the International Space Station is currently orbiting at about 150 miles up, maybe slightly higher. It varies its height. And at that height, the vacuum levels are quite severe. Not as severe as they are on the moon. You get to the moon, you've got real problems, because the vacuum levels on the moon are at least double what they are at the International Space Station.
Okay, so they pressurized the camera so that the film there wouldn't be any outgassing. Isn't that as simple as that?
It's as simple as that, and that's what occurred in the Hexagon spy satellite. Quite a big thing. It's about the size of a school bus. It's about 40, 50 foot long, 20 foot in diameter. It's quite a big piece of kit. It was launched on the Titan III rocket from Vandenberg Air Force Base. As I say, it went into polar orbit. And inside this satellite, the Hexagon spy satellite, there was a separate container which held all the film stock and the cameras and the tubing, the quite complex tubing through which the film was fed in order to take it from the photographic reels on which it was stored through the cameras. In front of the cameras they had rotating mirrors, because the satellite is orbiting quite fast, So you had to eliminate the apparent movement of the Earth beneath the satellite. It's a very complex system, but extremely effective. Now, the remarkable thing about excellent spy satellite is that once the photographs had been taken, the film was then wound onto what was referred to as buckets. The buckets were dropped from the satellite, and get this, they were caught in giant fishing net type contraptions being flown by aircraft out of Hawaii, and they were caught as they fell out of the sky. They actually only missed one. One fell into the Pacific, and they had to get it back so the Russians didn't get hold of it and find out what they were doing.
So the long and the short of it here is, Marcus, you're saying that in order to prevent outgassing of the film on the moon, they would have had an elaborate type of container in the vacuum of space to prevent that. And there's no evidence that they had anything like that. Is that the idea?
That's exactly the point. Yes. In order to prevent the outgassing of the film, and also in a vacuum photographic film, or the backing of it, the base, the ESTAR base, gets very brittle, and it wouldn't then go through the rather complex mechanism in the Hasselblad film magazines.
Now, the Hasselblad cameras that they used on the moon, how were they modified? I'm guessing that they weren't the type of Hasselblad that you use.
To be honest, they're fairly similar. A Hasselblad camera is a magnificent piece of kit. It's built almost like a Swiss watch. It's extremely complex. You can go to a shop and buy one today, which will look quite similar, ironically, quite similar to the Lunar Hasselblad cameras. They cost about $45,000, but you can still go out and buy one if you want to. And they're very, very good cameras, mainly because the lenses were particularly good. They were made by Zeiss. And the mechanism of the Hasselblad camera was modified slightly, because if you can imagine the picture of an astronaut in his full spacesuit, because you can't wear half a spacesuit in space, you've got to wear the whole lot, the helmet, the gloves, the boot,
Indeed,
the whole thing.
Yes.
If you're wearing a spacesuit, you can't get your head down to look through the viewfinder of the Hasselblad, which is on the top of the camera. And because it's also a single lens reflex camera, you look through the lens in the same way that the light coming in and records on modern day cameras on the CCD chip, the digital chip, in the older style cameras. These are film cameras, and anybody who's never used a film camera, this will all sound very 20th century and very weird and historical, but this is the case. This is what happened. So there was no viewfinder on this camera. And the click that you hear when you take a photograph is normally the mirror moving out of the way of the light coming in to hit the film behind it. So there was no mirror, because you couldn't get your head down to look through it, so they didn't have a viewfinder.
So they were just guessing.
Well, they were pointing it with their body. There are many photographs showing astronauts wearing their Hasselblad cameras. They were mounted on a special bracket on their chest. So they would move their body to presumably point the camera at the place that they wanted to photograph.
And would they be using an extremely wide lens just to give them, so they would be more forgiving in terms of the framing?
It was a slightly wide-angle lens. It was a 60mm lens on the Hasselblad. It's a Biogon lens, 60mm, which is the equivalent of a 35mm lens on a 35mm camera. So it's a slight wide angle. Yes, it's quite right. And obviously with a wide-angle lens, you've got more room for error. You don't have to point it very accurately, which you would have to do if you're using a telephoto lens. And those were available for the Hasselblad camera, and on the later missions they used 500mm lenses, which have a very, very small angle of view.
Did they have automatic focus?
No, there was no automatic focus. The focusing you had to do by moving what's called the focus ring, which is on the lens. You set your aperture, which is the f2.8, 3.5, 5.6, f8, f11 and so on. You set that on the lens, and you set the shutter speed, 125th, 250th, you set that on the lens as well. And you had to do this manually. There was no automatic function.
Wearing those enormous garden gloves.
Those heavy-duty gardening gloves were very simple things to use to focus a camera with. Have you ever tried doing it? I don't think...
No.
If you were having your wedding photographs taken, you wouldn't be very pleased to see the photographer wearing heavy-duty gardening gloves to focus his camera, would you? No, you wouldn't.
No, indeed. And of those 121 photos, I don't know how many of those had, let's say, if it was Neil Armstrong with the camera, I don't know how many of those were of Buzz Aldrin. Were there any with his head cut off? Because, I remember those old cameras. My grandmother, she was always cutting our heads off in our pictures.
That was always one of the problems with not using a viewfinder. You tended to either cut the head off or get the thing off center. Of those 121 photographs, there are no heads cut off. There are one or two that are, shall we say, rather poorly composed. The official description is inadvertent shutter release, which means that they fired the camera without pointing it at a particular subject.
And none of them are out of focus?
There are a couple that are out of focus, yes. They're not 100%, but they come close to being 100% accurate. There's a sequence of 8 photographs. And most people are familiar with the sequence of Buzz Aldrin climbing down the ladder of the lunar lander, which is called the Eagle. There's a series of 8 photographs. The first one is of his feet coming out through the door of the upper section of the lunar lander. And then you see him standing on top of the porch, and he comes down the ladder. And then Neil Armstrong, who's taking the photographs, decides he would much rather take a photograph of the rubbish bag, which he had thrown out of the craft earlier, and the footpad of the lander. I say there's a series of 8 photographs. 6 of them feature Buzz Aldrin, and 2 of them one of them features the rubbish bag, and the other features the foot of the lander. Presumably they had to make sure it wasn't damaged, so quite what they would have done if it had been damaged, history doesn't relate, because there's no rescue service on the moon. Now, any photographer will know, if you'd used photographic film, once you'd taken the photographs and you developed the film, you wanted to see what the images were that you had taken. And you would produce what's called a contact sheet, for the simple expedient of spreading out all the negatives onto a sheet of photographic paper, exposing some light to it so it exposed the photographic paper, and you could then have a look at all the photographs you had taken in the sequence you had taken.
Right. It's a positive image of the film strip. There's no enlarging or anything.
That's right. No enlarging. It's just a positive image. It's the same size as the negative. Most people would be using 35mm negatives, which are relatively small. The Hasselblad used 70mm negatives, or positives in the case of the colour film, and negatives in the case of black and white. These were larger, so they gave very good quality images, because the larger the negative, the better the quality and the higher the resolution. But if you look at the photographs on the websites, where you can see them all in sequence, all 121 on what's called magazine number 40, there weren't 40 magazines, it just happened to be the number that NASA chose to identify it. Magazine 40, it's on AS11 40, and then there are 121 photographs on that magazine. There was one other magazine used, magazine 37, and I believe there was one magazine 44. Anyway, you can go onto the website, you can see all the photographs taken, and on the lunar surface, in total, there were 5,771 taken by the 12 astronauts who walked on the lunar surface, we're told. Those photographs exist. You can go online and you can find them. The point about this is that Neil Armstrong is using a camera that has no viewfinder. He's taken Buzz Aldrin coming down from the ladder. Now, if you look at it, you'll see that the ladder down which Buzz Aldrin is climbing is in shadow. The sun is on the other side of the lander. The point is that Neil Armstrong not only has to focus the camera on Buzz Aldrin on various positions on the ladder, he then has to change the aperture and the focus to photograph the rubbish bag, and he has to do it again, change the focus and the aperture, because the landing leg he takes photographs of is in direct sunlight, so it would be a smaller aperture to compensate for that. The photographs are very, very well exposed. They're also very well framed. How did Neil Armstrong do it? We all know he's a very, very good test pilot, but was he a brilliant photographer? These are professional level photographs, professional standard photographs.
Right, they're just too good. Let's talk about the mechanics of the camera. You say the Hasselblad is built like a Swiss watch. It's a very precise mechanical device. How would that camera operate on the extreme temperatures and tremendous variance?
There's a huge range of temperature, which is one of the problems. The temperature in the sun on the lunar surface, because there's no atmosphere on the moon, therefore light from the sun would immediately be at plus 120 degrees centigrade, higher than the boiling point of water. If you move into the shadow, in this case of the lunar lander, the temperature will immediately fall to minus 120 degrees centigrade, colder than any temperature that we experience here on Earth. The lowest temperature we experience on Earth is in Antarctica, which is minus 80 degrees centigrade. So you've got an extreme range of temperature. Now, because there is no atmosphere on the moon, a vacuum, besides its other properties, is a very good insulator. But the effect of sunlight hitting any object on the lunar surface will be to heat it up instantly, or as fast as the heat can be absorbed. Heat will be radiated away, but there's no convection like we have here on Earth, where you've got an atmosphere. There's no conduction, which is where you've got heat traveling through an object. You only get radiant energy. One of the other problems with this camera, as I say, it's a brilliant piece of equipment, but we know from the photographs we see of the Hasselblad camera, and there are film cameras as well mounted in the lunar lander. It's a Maurer 16mm film camera, which operates in much the same way as a stills camera. There is no pressurized container around the camera, none whatsoever, and it would be visible if it existed. It doesn't exist. There is no pressurization of any of the Hasselblad cameras or any of the Maurer film cameras. So we have a real problem here. How did that photographic film survive in the vacuum of space on the moon?
Have you used the Hasselblad in extreme conditions here on Earth?
I've used a Hasselblad in fairly warm conditions, yes, but just a warm summer day over in England, which maybe people might say, well, that's not going to be very warm, is it? One can operate a camera in a fairly comfortable range of temperatures. If you're starting to use it in Antarctica or in really severe weather, like I believe you get in Canada, you might start getting problems, because one of the things that happen is that film starts to go very brittle in low temperature and it starts to break. That's why when it outgasses in a vacuum, it starts to break.
Right. What about the mechanics of the camera itself, like the shutter itself?
Yeah. The shutter is mounted in the lens of the camera, and it's what's called an iris shutter. There are about 6 different parts to the shutter. Now, these are normally lubricated, as are all the mechanical components, which is exposed. It has to be then, the film has to be moved to the next exposure, and that's done by mechanical means driven by batteries. It's the only automatic feature on the Hasselblad camera. The film advanced. So you've got batteries in this camera. In a vacuum, I don't think so. Also, any lubrication of the moving parts, and there are gears inside the magazine which advance the film, those have to be lubricated. Because without lubrication, metal starts to bind together. Lubrication in a vacuum will immediately start to outgas or boil, which is what water does in a vacuum. It boils because you lower the point at which the boiling can occur. Outgassing is where the volatile elements of any liquid are basically forced out by the vacuum. Just as an aside, there is a phenomena called cold welding, where 2 metals, if they touch in a vacuum, are instantly welded together. It's to do with the lack of any molecules which will separate them. If you're in a vacuum, there is no air to separate anything you put in, and metals touching each other will cold weld, which is a phenomena which was only discovered once people started going into space.
There is no way, unless there were significant modifications to these cameras, that they would be able to operate in the vacuum of space, in the extreme temperatures in space.
Exactly. One other point, when you're going to take a photograph, you've got to press the shutter button. On a Hasselblad, the shutter button is always on the front of the camera. Now, this was modified, so it was about 1 inch square, but you still couldn't see it from inside a spacesuit. So how did you know you'd actually reached it? You were supposed to feel around and prod around until you made sure you got your finger in the right place. And also, you didn't know if you'd taken a photograph, because the film counter dial is on the side of the camera, and you couldn't see that from inside the spacesuit.
What about the radiation? We're all familiar with, those of us old enough to remember taking film through the airport, then you would pass the high-speed film anyway. You would pass that to the person, and they would bypass the machine and so forth. So talk to me about the radiation and film.
That's one of the key points about the whole questioning of the Apollo missions, because aside from various other problems which we might come on to later, one of which is re-entry, the radiation experienced in space, about 500 miles above the Earth's surface, you have something called the Van Allen radiation belts, which are belts of radiation, and these are quite severe problems. And as you say, if you didn't take your photographic film out of your camera and pass it through to the attendants so that they could hand examine it, the film could be damaged unless you had it in a lead-lined box, which is the other way of doing it. Because photographic film is susceptible to radiation. Electromagnetic radiation is called. That's what visible light is. It's radiation. Films are designed to record radiation, but only at certain levels. If you have too much radiation, you'll damage your film. It'll become what's called fogged, which makes it look as if it's taken in a cloud or a bunch of steam or something like that. And this was demonstrated very clearly at Chernobyl nuclear disaster, where several people did have cameras. They did take photographs at the time that the reactor blew up, and the photographs which they obtained were seriously damaged by the radiation which they were experiencing. I mean, it affected them as well. Several people died as a result of it. But photographic film can be damaged by radiation. And this is why, if you ever bought a roll of photographic film, and we are talking photographic film, not digital here, photographic film, you would buy it, and it had an expiry date on it. Why would photographic film have an expiry date? It can't rot, it's not a piece of food. The reason it had an expiry date was because the manufacturers of the film, Kodak or Fuji or Ilford or Agfa, they didn't want their customers to come back to them a few years later and complain that the film that they bought, say 5 years earlier, really wasn't producing very good pictures. They all looked a bit sort of foggy and contrast levels weren't right. And the reason is that background radiation, if a photographic film is exposed to it for long enough, it will absorb sufficient radiation to damage the film, just if it sat in your drawer at home. So radiation is a major problem. There's a great deal of discussion about how much radiation is there in space. The normal answer will be, well, it's like getting a couple of chest x-rays and it's nothing to worry about. Don't concern yourself with it. The astronauts are all fine. Look, they all went to the moon, they got back, they must be all right. So it can't be much of a problem. That's the normal argument given by people who support NASA. And fair enough, you want to feel that an organization as competent as NASA is doing the best thing, and they must have known that radiation wasn't a problem, or they wouldn't have sent astronauts out onto the moon, would they? Well, why didn't the Russians go to the moon? The reason they didn't go to the moon was because they knew the dangers of radiation. And they said, we will not be sending any cosmonauts to the moon until we can ensure their safe return due to the dangers of radiation. So they knew about the problems.
And none of the photographs show any evidence of fogging whatsoever. Not only the 121 from Apollo 11, but let's talk about, how many did you say across all the Apollo missions?
There were 5,771 photographs taken on the lunar surface. There were about another 25,000 taken by various astronauts as they went to and from the moon and in orbit around the moon in the command module. So there were quite a lot of photographs taken allegedly beyond Earth. Because if radiation is as big a problem as it appears to be, and there is still a great deal of dispute about this, then how come nobody else has been to the moon? 1972 was the last alleged mission. I say alleged because I have very serious doubts that it occurred the way we were told.